Okay, so the question that we have is saying a rocket is being shot vertically upwards with an initial velocity of 400 meters per second. Its height s after t seconds is indicated as 4 400t minus 16t squared. So how fast is the distance changing from the rocket to an observer on the ground 8, 1800 or 1800 meters away from the launching site when the rocket is still rising and is 2400 meters above the ground. Okay, so what we need to do here is to try to create a picture of what this is trying to tell us. Okay, so let's say one of the information that we have been given is that the observer is 1800 meters away from the launching site. So if we are to say this is our launching site here, if we are to say this is our launching site at this point, we say this is our launching site. Okay, then we are told that the observer is 1800 meters away from this launching site, so you can decide to go this side or the other side. uh, we are basically talking about the same thing. Okay, something like that. So let's say the observer is at this point. Okay, we have the observer here, just indicate using O. Right, and the distance between this the between O, where the observer, and the launching site, let me indicate using L, is 1800 meters. Okay, that's what I've been given. Then we are told um, we are told to say, we are given further information to say when the rocket is still rising and is 24 20 2400 meters above the ground. So it's more like it's going up. Okay, 200 meters above the ground. Okay, something like that. So at this point here, between the launching point and that point, what we have is a 2000. What we have is a 2400 meters. Okay, so want to try to create a relationship here. The question is that how fast is the distance changing? It's more like between the observer and the rocket. So the distance between the observer and the rocket, if we say the rocket is at this point, if we say the rocket is at this point, okay, the distance that is changing is the distance from this point to that point. Remember to say at first, it's more like as it was going up, it was moving like that. We had, so it keeps on going up and up, up, just like that. So the distance, this is d there, or indicate as d, that is continuously changing as the rocket is going higher. Of course the observer is still maintains the same point, but the distance d there keeps on growing. What does it mean? This is just basically Pythagoras theorem, meaning this value here is going to be increasing time to time. All right, so meaning as it is increasing, the hypotenuse, which is d in this case, is also going to be increasing. So what we want to try to find out is a relationship between the distance that is changing and this side that we have here, as well as what, as well as that side there. So what we can do here is we can try to create a relationship between the changing distance. If we are to indicate it like this, if we are to indicate it like that, so the changing distance, let's just use what, use h for the hypotenuse. Then this side we can use what, y, and this side we can use x for the 1800. So we want to try to create a relationship between or the relationship on what we have here, the h, the x, and the y. Okay, so this basically means if we were to use Pythagoras theorem, our h squared will be equals to our x squared plus what, plus our y squared. Okay, then our h squared here is the one that we are looking for. So we are saying our h squared here is equals to our x is basically 1800, we say squared, plus then our y squared we have been given as what, as s. Okay, and you know to say our s is equals to uh, that, but I'll just indicate using s and we say squared like that. Okay, so the rate of change of h with respect to time, for us to be able to find that, we need to differentiate both sides of what we have, this side and that side. So here what we are going to have, if we are to differentiate that with respect to time, we are going to have 2h this side, 2h dh dt, okay, is equals to, this is a constant here, you get a 0. Okay, then on the other side you're going to have 2s multiplied by ds dt. Okay, so here I guess we can get rid of the 2, we can cancel it out, it's appearing on both sides, this can go and that can go. I mean that, yeah. So what we have now, what we have is that our h dh dt will be equals to our s ds dt. So this is the relationship between what? The relationship between the rate of change of h and dt. But we want to try to make dh dt the subject of the formula. How do we go about that? So here, what you're going to have is your dh, okay, dh dt will be equals to s ds dt. We're going to say multiply by 1 over h like that. Okay, so in this case, want to try to find out what our s is. We have been told that s at some point is what? S at some point is 2400 or 2400. Then the s dt, we just have to differentiate what we have here. Then the h there, we just have to use Pythagoras theorem to do what? To find what h is. So in this case, I don't want to leave out the way h is here as well as the way s is. I'll use the s that I have to find what my h is there. So if I use Pythagoras theorem here, we're going to say our h will be equals to the square root of 8,000 1,800 rather plus 24,400 squared. um, that is going to give us something like, if we say 1,800 squared plus 24,000 2,400 squared, you're going to get a 300. So our h here is equals to what? Is equals to a 300, not 300 but 3,000 rather. Okay, so we have what our h is and we have what our s is. So meaning h at 2,400 is simply 3,000. So we can say our dh dt is equals to our s at 20 uh, our 2000 at 2,400. Then we still have our ds dt there, multiplying by 1 over the 300, I mean the 3,000. I wonder why I'm still I'm saying 300 over and over again. Yeah, but it's a 3,000. So we can we can try to simplify that. Okay, we can try to simplify that. We are going to have our dh dt being equals to 24 over 30 ds ds dt. Okay, ds dt there. So I would also want to try to work out what the SDT is. Okay, we'll try to work out what the SDT is. So we have been told that our S is 400t minus 16t squared. So we need to find the derivative of that. So when you differentiate 400t, you're going to get a 400 minus, when you differentiate 16t squared, you're going to get 32t like that. So meaning our dh dt uh, is equals to a 24 over 30 multiplied by a 400 minus 32 t like that. So distributing that fraction that we have as the coefficient into the brackets, what you're going to have is something like you're saying 24 over 30 multiplied by 400, you're going to get 320 minus then 24 over 30 multiplied by 32, you're going to get something like 25.6 t. Okay, so this is basically this is the equation that you're going to be using. This is how h is going to be changing with what, with time. So this is we have been given distance in meters, then time in seconds, so that would be meters per second. So how you even of course, what you do here is that if you want to find the exact value at that point, because this is the point that we used at 2400 meters vertically upward, going upwards. If you want to find the exact point, okay, you need to find time. Okay, you need to find time at this point. How do you find time at that point? You just equate where there's s here, we equate with what, we replace it with the 20, with the 2400. Then we find what time is going to be. So you're going to have 2400 being equals to 400t minus c 16t squared, like that. Then we need to find the value of t. When you replace there, you're going to find the exact value at t at that point. But otherwise, this is the expression that tell us the rate of change of height with respect to time. So you can try it out. Try to find what that exact value is going to be, and you can leave that in the comment section. Yeah, so that's all in this video. Thank you very much for watching.